Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 310. Please turn to it. Page number 310, and today is our lesson number 27. The very first problem on the page, number 28. Problem number 28. We are simply asked to simplify this expression, x squared minus 4x plus 3 minus 3x squared minus 4x minus 3. Well, listen, the only thing that we have to be careful about, only thing that we need to worry about in this case is this negative sign in the middle. But this part is not going to change. This is just x squared minus 4x plus 3. But when we open this parenthesis, this negative has to be distributed to all the terms here. This is a positive 3x squared. Negative times a positive will become negative 3x squared. Again, negative times negative will become positive 4x. And negative times negative again will become positive. That's all. That's the only thing we need to worry about. Negative times negative will become positive. Negative will become another positive, and this will become negative. That's it. Now all we have to do is collect the like terms. That's how we speak. Collect the like terms. Collect the like terms. Now what does the word like mean in this context? What does the word like mean in this context when you say collect the like terms? It simply means collect the similar terms. I make a fuss about it because sometimes I'm surprised to find out that kids actually speak the language but they don't quite understand what they're saying here. Collect the like term here, the word like here is not as in, the word like here is not as in I like you. That's not what it means here. Like in this context means similar. And of course the antonym of like would be unlike. For example, 3 here and 4x here, because it has x with it and 3 does not have any x with it, these two are unlike terms. These two are dissimilar terms. We have to collect the like terms. So the like terms are these. Here I see x squared and here I see x squared. Here we have a positive 1x squared and here we have a negative 3 squared. Positive 1 and a negative 3 will be negative 2. Negative 2x squared. That part is done. Now I see 4x here and I see 4x here. Oh, positive 4x and a negative 4x. What do you know? They're going to cancel out. That's it. We are done. And then we have a constant of 3 and a constant of 3. Positive 6. That's it. We are done. That's our answer. That was actually simpler than I thought it would be. That's it. We are done. Number 29. Next question, number 29. In number 29, we are told that M happens to be median of 9 data points. Then we are told that we are going to add 4 more items to the list. 4 items are added to the list. We're going to add 4 more data points to the list. We are told that 2 of them are going to be less than median and 2 of them are going to be greater than median. Now, if you don't quite see exactly what's going on, if you don't quite see right away what's going on here, then the simplest thing, the easiest thing, the most economical thing for us to do here is what? The most economical, the most simplest thing would be to make up your own problem. Yes, it's okay. It's okay to make up your own problem in the exam. When they say a list of 9 data points, you go tell them to F themselves. You understand? So I don't want to deal with 9 points. We're going to make up, let's make up fewer points. What's the least number of points we need? What's the least number of data points do we need in order to convey the concept of median? What does median mean? Median means it's a number that falls in the middle after the numbers have been arranged either in the ascending order or descending order. One more time. Median is a number that happens to be right in the middle after you have arranged all the numbers either in the increasing order either in the ascending order or in the decreasing order, either in the descending order. But they have to be arranged in order. Once you have done that part, once all the numbers are arranged, then anything that falls right in the middle is the median. And for that concept to come through, we need minimum of 3 points. So that's what we're going to do. We're not going to say 9 points, we're just going to say 3 points. And we're going to make up our own problem. Let's do it. So here are my 3 numbers. Here are my 3 numbers. 5, 3, and 9. Well, first thing we have to do is arrange them in order. So let's do that. Let's arrange them in order. 3 is the smallest one, then 5, and then 9. So this is the median. So far so good. Now we want to add 4 items. We want to add 4 items so that 2 of them are smaller than the median. 2 of them are smaller than median. So just let's add 2 more numbers that are smaller than median. Median is 5. Let's add 0. 0 is smaller than 5. And let's add negative 3. Negative 3 is less than 5. And then it says we're going to add 2 more that are greater than median. So let's add 2 more. How about 27 and 27 raised to 27? Well, there you go. I'm pretty sure that 27 raised to the power of 27 is more than 5. And of course 27 is more than 5. So there you go, we have done it. We have added 2 numbers. We have added 2 numbers that are more than median. And we have added 2 numbers to the list that are less than the median. Does that affect the median? Does that do anything to the median? The answer of course is no. Because median by definition means the number that is sitting right in the middle. Well, if the number is sitting right in the middle already, and you go around adding numbers to its left and to its right, the numbers that are smaller than it and the numbers that are greater than it, is not going to affect the order. It's not going to affect the order. It might affect the order here or here. For example, instead of 27, had we added 8 here, then of course we would have to switch. The 9 would have gone there and the 8 would have come here. But it's not going to affect the 5 itself, because these are more than 5. These are more than 5, which means they are to the left of 5. Similarly, anything that is less than 5 is to the right of 5, which means 5 is going to remain in the middle regardless of what happens. As long as the numbers that we are adding are more than the median, it's not going to affect the order. As long as the numbers are less than a median, same numbers that is. If you add 2 to the left hand side, 2 to the right hand side, it's not going to affect the order. Do you understand? That's all it is. You can't go around adding 2 that are more than 5 and only 1 to the right. Then of course we'll have fewer numbers. Then of course it will affect the order. But as long as we add same number of numbers to the right, same number of numbers that are more than median, and the same number of numbers that are less than median, the median does not change. The median does not change. That's all. And the answer is B. Median does not change. Median does not change. Similarly, by the way, similarly, if you make the largest number, making the largest number even larger, or the smallest number even smaller, also does not affect the median. Even though this question does not ask us about this concept, but I figured since we're talking about this concept, let's talk about this concept as well. So what it says is that similarly, making the largest number even larger. So if you have a set of numbers, let's start with something simpler again. So here are the 3 numbers. Let's say 3, 5, and 9. So here are the 3 numbers. They are already arranged in order, and the median is 5. Median is 5. Now you take the largest number. And you make it even larger. Making the largest number even larger is not going to change the median. So if you have 9, and if you turn that 9 into 90 million, well, it's not going to affect the order. The order is still the same. The 5 is still in the middle. Similarly, if you have a set of numbers, it doesn't have to be 3 numbers, you can have a whole set of numbers, and as long as they are arranged in order, then whatever number happens to be the median, that median is not going to change if you take the smallest number and make it even smaller. So if you take your 3 and convert it to -3, again, it does not affect the order. decreasing the smallest number or increasing the largest number also does not affect the median. Let's do the next problem, shall we? Number 30. Number 30. What does 30 say? In 30 we are given two circles that are tangent, two tangent circles like this. Here is your large circle, there is the center of the circle, and here is the smaller one, and they touch each other only at one point. Even though mine does not look like it, it touch one point. This is the center of this circle, this point is the center of the large circle. In other words, the diameter of the small circle, diameter of the small circle equals the radius of the large circle. This is the diameter of the small circle, and that diameter of the small circle happens to be the radius of the small circle because this is the center. And the question simply is, how much is the shaded area? What's the area of the shaded region? Let's find out. Area of the shaded region is going to be very simple. Area of the shaded region is going to be simply the area of the large circle, minus the area of the small circle. Once we take away the area of the small circle from the area of the large circle, what we are left with is the shaded region. Area of the small circle. How do we find area of the large circle? Well, large circle, the radius is from here to here, which is the diameter of the small circle. And now so far on the blackboard I have not put any information. They must have told us what the diameter of the small circle is. Let's read it carefully. Oh, they actually tell you in the picture. They tell you that it is 10. So that's very simple. And that 10 represents the radius of the large circle. It also represents the diameter of the small circle. If this is the diameter of the small circle, which means the radius of the small circle is half of that, which is 5. So pi r squared, the radius of the large circle is 10 squared minus pi times 5 squared. That's it. This is 100 pi minus 25 pi. 100 pi minus 25 pi would be, of course, 75 pi. The answer is 75 pi. That's K. This, by the way, is my pi. In case you're confused about it, I know I make a very sloppy pie. It's supposed to be very fancy. It's supposed to have something like this. I don't do any of that thing. I'm just lazy. Number 31. The last one on the page. Number 31. We are told, it says, which of the following sets of three numbers could be the side length in meters of a 30, 60, 90 triangle. They just want to know if you know your 30, 60, 90 triangle. Let's find out, shall we? "30, 60, 90 triangle." Do you know this word? Do you know this word? Mnemonic? Of course you do. Mnemonic is a memory device. Mnemonic is something that you make up to remember something. For example, PEMDAS is a mnemonic device. PEMDAS reminds us of the order of operation. Please excuse my dear Aunt Sally. Well, that's a mnemonic device. It's a mnemonic device. It helps me remember something. Do you have any mnemonic device to figure out what 30, 60, 90 degree triangle entails? What does it involve? I do. I'm going to share with you. Maybe you don't need it. Maybe you know your 30, 60, 90 triangle. I don't. I have to have the mnemonic device to make my life easier. What I say to myself is this: 30, 60, 90 degree triangle has how many different kind of angles? Well, obviously there are three different kind of angles. There are three different kind of angles right here. There is a 30 degrees, a small angle. There is a 60 degree, a medium-sized angle, and there is a 90 degree. There are three different kind of angles. So I'm going to put down 1, 2, 3. You with me? Stay with me in this story, okay? Then what you do is you take the last number and you put a square root sign on it. Are you still with me? That's it, we are done. Now all we have to do is take this number and arrange them in order. The largest number is which one? Let's start with the smallest one. Root of 3, I hope you are able to tell, or you are able to see right away, the root of 3, whatever it is, has to be less than 2 and more than 1. Square root of 1 is 1 and square root of 4 is 2. If the square root of 4 is 2, then square root of 3 has to be less than 2. That falls in the middle. 2 is the largest one, 1 is the smallest one. So the smallest angle that you see here is this angle. 30 is the smallest angle. The side facing the 30 degree, which is this side right here, will be the smallest side. Similarly, this let's give them names so we can talk about them. ABC. The side AB faces the 90 degree. It faces the 90 degree. Since it faces the 90 degree, it is the largest side because it faces the largest angle. And 60 is the medium-sized angle. It faces the medium-sized length, which is root 3. That's all. There is a 30, 60, 90 triangle, which means that the three sides in the 30, 60, 90 triangle, they have to be in this ratio. 1, root 3 and 2. 1 to root 3 to 2. Or any multiple of it. Here they're very nice, they don't actually give you multiples, they just give you this thing, 1, root 3 and 2, which is answer choice E. What I'm trying to make you understand is that instead of giving these three quantities in the answer choice E, had they given us something like this, say for example, if they had given us 5 times root 3 and 5 times 2, which is 10, 5 times 2, which is 10, had they given us something like this would also have been correct. This one is a 30, 60, 90 triangle, except this triangle is 5 times as large as this triangle. The side BC, instead of being 1 foot long, in this scenario, that side would have been 5 feet long. The hypotenuse being 2 feet long, in this scenario, it is 10 feet long. In other words, it's the same triangle, magnified 5 times. That's all. I will see you tomorrow, okay? Oh, by the way, if you want, I can give you very quickly the mnemonic device for a 45, 45, 90 triangle. Same exact system. Okay, watch what happens. In a 45, 45, 90 triangle, I can make them equal. There. A, B, and C. These two sides are equal. This is 45 and this is 45. How many different, and this of course is 90. How many different angles do you see here? Well, I only see two kinds of angles. I see 45 degree angle and I see 90 degree angle. There are only two kinds of angles. Therefore, I put down 1 and 2. I take the last number, put a square root sign on it. And then I just arrange them in order. 1 is smaller than root 2, so 1 is going to face 45 degrees and 45 degrees, and 2 is bigger than this, and therefore 2 is going to face the larger angle, which is root 2. There you go. 1, 1, root 2. But of course in a 45, 45 triangle, we don't have to make such a big fuss about it, because of course we can very quickly figure out using the Pythagorean theorem. Very easily we can figure out using the Pythagorean theorem. It tells us that if this side is 1 and this side is 1, then the hypotenuse would have to be 1 squared plus 1 squared. 1 squared plus 1 squared is 2, and therefore A to B is got to be square root of 2, which is where this comes from. Do you understand? I'll see you tomorrow, okay? Bye now.